Now in 5.1, we're going to be talking about factoring. And there's several different techniques that we're going to be discussing. The first one we're going to look at, and that we always do before anything else, is take out the greatest common factor. And when we factor, it's kind of reverse multiplying in a way. So we're going to learn how to take out the greatest common factor. Now, when we take out the greatest common factor, that can be just simply a number, all right? That can be a number and a variable, and that also might even be a grouping or a set of parentheses that comes out. So we want to take out the greatest common factor on these. We'll start off with some simpler ones, and then we'll gradually increase the level of difficulty. And once we understand how to take out the greatest common factor, then in 5.1, we're also going to learn how to factor by grouping, which builds into 5.2. So we're going to learn first off how to take out the greatest common factor. And we're going to start off with a very, very simple question here. 4a plus 10. Now we want to take out the number or the variables or both that's in common here. They don't have the same variable a, so that can't come out. But what we do have is we have a 4 and a 10. Okay, and a 4 and a 10, well, they have a 2 in common. So what I can take out of this is a 2. So I can take out a 2, and then we divide. 4 divided by 2 leaves you with a 2a, and then 10 divided by 2 leaves you with a 5. So we took out the greatest common factor, which was a 2. And the reason why we did that is it reduces down the size of the numbers inside. We went from a 4 to a 10 to a 2 and a 5, which are smaller and easier to work with. Okay, let's do another one with some more parts to it. And we're going to, again, take out our greatest common factor. Now this one, we cannot take out an x because that 2 does not have an x on it. But what we can take out is we can take out a 2 again. And I picked this one on purpose because whenever a number goes completely away, you leave a 1. So 8 divided by 2, that leaves you with a 4, x squared. We've got a 6 divided by 2, that leaves you with a 3x. Now, 2 divided by 2. 2 divided by 2 is a 1. So it's not gone, you have to leave a 1. Always count the number of terms. When you take out the greatest common factor, you're going to have the same number of terms. Like on this one, we started with 2 terms. We're left with 2 terms inside the parentheses. On this one, we got 3 terms, right? 3 terms are left inside the parentheses. So the number of terms has not changed when you take out the greatest common factor. And that's what we're doing here, is we took out the greatest common factor. We can also take out a variable and a number or just a variable. So let's do another one. Let's look at a, how about a 9x to the 5th, a, minus 6, x cubed, a, and then how about plus 3, a squared, x. So we, again, want to take out our greatest common factor. So the first thing we look at is we look at our numbers. So we have a 3, a 6, and a 3. So what numbers does 3, 6, and 9 have in common? 3. Okay, so a 3 is going to come out. So the 3 will come out and get placed in front. Do the numbers first. What else comes out? Then we look at the variables. All right? They all have x's, don't they? So we take out the smallest power of the x. So we have a 5, a 3, and this one just has a 1x. So the only thing that we can take out is a single x. What about the a's? This one has an a, and this one's an a squared. We cannot take out an a squared. We take out the smallest power, which is simply a. So what are we going to take out now? We're going to take out a 3xa. And you could write that as 3ax. It's not going to matter. Order in which you write them is not important because that's commutative. Normally I write the x first, but either way, if you want to write ax first instead of xa, that's okay. So we're going to take out a 3xa. So now we write them out and we divide. 9 divided by 3. 9 divided by 3 is a 3. We've got an x to the 5th. Take out one of them, so that leaves you with an x to the 4th. The a comes out and cancels with the a out in front, so it's gone. Then we have a minus 6 divided by 3. That's a minus 2. How many a's do we have? We have 3 of them. Take out one of them. That leaves you with an x squared, doesn't it? There's no a's because the a came out and is gone. Next, 3 divided by 3 is a 1. We can write the 1, but we don't need to unless everything else is gone. But there's going to be something left. Okay, so we leave the 1 there. What about the a's? We have 2 of them. 1 comes out, so 1 is left over, and the x is gone. So that is my final factored answer. And again, this is taking out the greatest common factor. Okay, so we're going to be taking out the greatest common factor here. Let's try another one. And then we'll look at how to handle parentheses. So let's try another one. Let's try to take out again the greatest common factor. And let me come up with something that'll work. And I'm going to give you 4 terms this time. About 27 a cubed x to the 5th minus, let's say, a 3 a squared x to the 4th plus, let's do a 81 ax to the 9th. And then let's do a minus here. How about a minus 9y squared? Okay, now, here's where students sometimes will make a mistake. To factor out a variable, each term or each part has to contain that variable. This one's got an A, an A, an A. Does this one have an A on it, on the end here? No. So can an A come out? No. What about the X's? This one doesn't have an X on it at all, does it? So can an X come out? No. So in this case, what is the only thing that I can factor out? I have a 27, 3, 81, and a 9. There's a number that can come out, and what is the only number that can come out of here? Anyone know what number can come out? 3. Okay, that's it. So I picked this one on purpose to illustrate the fact that this one does not have an A and it does not have an X, so nothing comes out. If this had an A on it, I could take an A out, but it doesn't. So the only part that can come out is the number 3. Now we just simply divide again. 27 divided by 3. 9. Nothing else comes out, so it gets copied as a cubed x to the 5th. 3 divided by 3 is 1. We don't have to write the 1, but we do need to bring the negative down. And that's a minus, and that's a squared, x to the 4th. 81 divided by 27. Well, 81 divided by 3. 81 divided by 3 is going to give you a 27 there. Sorry about that. And that's going to be a x to the 9th. And then what about the last piece here? 9 divided by 3 is a 3. Stays negative. And that's going to then be a y what? Y squared. That's it. That's all we needed to do. That was, again, taking out the greatest common factor. So that's what we did. These are all just taking out the greatest common factor. That's it. These have all been either a factor that's a number or a variable or both. You can also take out an entire set of parentheses. So if you've got two parentheses and they are the same, they can directly come out as the greatest common factor also. So here's one that we're going to take out that again has a greatest common factor. That in this case is a parentheses. Okay, so on this one, again, what am I doing? I am not multiplying in this chapter. I am taking out and I am factoring. So I need to see what is in common. So what do we have in common? It might be more than a variable. It might be an entire set of parentheses. Was this entire set of parentheses right here the same as this one? Yes. So the entire set of parentheses can come out. And that leaves you with an x minus 7a. Now, once that's gone, then we write out what's left over. So what's left over? 3x plus 5. So we took out our set of parentheses, we wrote it out in front, we crossed it off, and then we write what's left over. And this again was taking out the greatest common factor. You might also be able to take out a number. So let's say I give you a 25 a cubed times 4 minus 3a. And let's use a minus 5 a squared times 4 minus 3a. And this is the first one that we're going to have to actually factor twice. So when I look at this, the first thing I look at is I notice there's going to be two things I'm going to have to factor. I look at my numbers and I just see a 25 and a 5. So I know a 5 is going to have to come out eventually. But I always like to start with our parentheses, and I look at these parentheses and I see these are the same. So the first thing I would do is see those are the same, so I would go ahead and write it out in front. So out in front I have a 4 minus 3a. And so that's gone, and that's gone. All right, so that's came out in front, and what's left over? Well, what's left over is a 25 a cubed minus 5 a squared. This is the first problem where we are not completely done. Whenever you come up to a question on any of these, you've got to look and make sure that you cannot take more out. So we've got our two sets of parentheses, and I'm going to look at each one individually. Inside this first set of parentheses, I have a 4 and a 3. So those don't have anything in common. So that's done. However, on the next set, I think there's something in common here. On the next set, I've got a 5 and I've got a 25. So a 5 and a 25, what do they have in common? They have a 5. And I'm going to write that out in front of everything. So that goes out in front of all of it. And what else do they have in common? They have a's, and our smaller power is a what? Squared. So a 5a squared is going to come out. Now what's left over? Nothing came out of the first piece, so that's a 4 minus 3a. And what about out of the second piece? What came out of here? 25 divided by 5, that's a 5. A cubed, take out an a squared, that leaves you with an a. And then the minus 5 cancels with the 5 there. And the a squared cancels with the a squared. If it's gone, what do we leave? We leave a 1, and our sign is going to come down, and our sign is a what? Negative. So again, this was nothing more than taking out the greatest common factor. We'll do one more of these, and then we're going to learn how to factor by grouping. Okay, so we'll do one more of these, and then we'll add a step, and we'll learn how to factor by grouping. Okay, so on this one, we're going to have to factor out what we have in common, and then we'll probably have to factor it again and again after that. So let's look at this first, and let's see what we can work with. Well, when we look at these groupings have powers. Just like a variable, we always can take out only the smallest power. So this one's a 3, and this one's a 2. So the only thing I can take out is a 2a minus 3y quantity squared. So that's all I can take out of there. Now, what's going to be left over? I'm going to use square brackets because I've got a lot of parentheses and things to work with as well. So I'm going to use square brackets. That way we don't have double parentheses running around. So the 2a minus 3y comes out. And this is a kind of complicated one. Most of them are not this complicated, but this one just kind of illustrates all the different points. And if I take that out, I have a 9x to the 5th, right? And we have 3 of these, a minus 3y. So 2 of them came out. So we're left with an a minus 3y. And then we have an 81x to the 4th. And then none of those, right? So they're gone because that comes out all by itself, because that's completely gone because there's 2 of them, right? 2 of them came out, so it's gone. We don't have to put the 1 there. All we do is bring down that 81x to the 4th. Now, we can go a little bit further. Okay? So now we've taken out that 2a minus 3y, quantity squared. We look at what we've got left over. So let's look at each term. These are terms here. So this is an entire part. And we're going to compare this one to this one. What do we have in common? We have a 9 and we have an 81. So what do they have in common? 9. Okay. And then what else do they have in common? X to the 5th x to the fourth. What power do we take out? Smaller power. And what's my smaller power? X to the fourth. We place that out in front. Now we're going to keep the 2a minus 3y out in front. Okay, so that stays there. Now we see what we've got left. So let's see what we've got left. So the 9 came out. So 9 divided by 9, that left you with a 1. We have an x to the fifth. How many are we taking out now? 4. So how many are left over? 1x. Okay, so that's just an x there. We still have the a minus 3y. And then our last piece, 81. 9 came out. So that leaves you with then a 9. X to the fourth and x to the fourth, they're gone. Now we do need to do one more step. Okay, we need to break this down as far as we possibly can and clean it up as much as we can. So we need to work with this a little bit. And so I'm going to take this x now, and I'm going to distribute it through so we can get rid of the square brackets, and we'll only have left parentheses. So that x can be distributed through. So out in front, it all stays the same. So 9x to the fourth stays there. And that should be squared there. A 2a minus 3y, quantity squared, stays there. Now, that x gets distributed through. So that's xa minus 3y plus 9. So we distributed it through. Now, how do I know that I am completely done? Here's how I know I am completely done. I look at each set of parentheses by itself, and I make sure that nothing else can come out. So a 2 and a 3, nothing in common. A and a y are not in common. First set is done. Now, look at the second set. Do we have an x in common with all of them? No. And that should be an xy there. My mistake. Sorry about that. Don't forget your xy there. Oh, forgot. Because that x gets distributed through. So, x can't come out because it doesn't have that with the 9. We have a 3 and a 9, but the 1 has nothing in common here. So that's as far as we can go. Nothing else comes out. It's as far as you can possibly go with this. That's it. Now we're going to learn how to factor by what's called grouping. And this builds upon what we have just done with taking out the greatest common factor. So we're now going to learn how to factor by grouping. And factor by grouping requires 4 terms. And factor by grouping is when we have 4 terms. How we identify what technique to use is based upon how many terms that we have. We have a method that we're going to learn about today, which is when you have 4 terms. There's another method we'll learn when you have 3 terms, and then there's one when you have 2 terms. They're different, and they require a different technique for each one. We're going to learn right now first factor by grouping, which is when you have 4 terms. Step number 1 is always check to see if a greatest common factor can come out. So step number 1 is take out the greatest common factor. And this is going to be if possible. In many cases, there's going to be no greatest common factor. But if there is one, it has to come out at the beginning. So if there's a greatest common factor with all 4 terms, that comes out. If it doesn't, then we go on to step 2. And step 2 is you factor by grouping. And what we do is we group the first two pieces together and the last two. So we factor by grouping. So you group the first two together, and you group the last two together. Then you factor again, and write your answer. Right here. So factor again, and you'll write your answer. So let me find a couple of these to work out from the textbook here. This way they come out nicely. If I'm not careful, if I try to make these up, then they may not factor that nicely. So I'm going to try to pick some from our textbook so that they factor out nicely. So I'm going to look in page 348, and we're going to look at question 51. If you don't have your textbook with you or don't want to turn to it, that's fine, because I'm going to write them up on the screen here. These are factored by grouping. So we've got an mx plus qx plus my plus qy. Okay, so let's go through our steps here. I am going to apply factor by grouping. Why am I going to apply factor by grouping? Because it has 4 terms. The number of terms dictates the method that we use. So we've got 1, 2, 3, 4 terms, so it's factor by grouping. Now the first step, you may or may not have a common factor. In this case, we don't have a common factor, do we? Because not all of them have m's, not all of them have y's, not all of them have x's or q's. So nothing comes out. Now, if they all would have had a 3, you would be able to take out a 3. You always have to do that first. In this case, though, nothing comes out. Always, though, check it first. Step number 2 is we factor by grouping. So we group the first 2 pieces together and the last 2 together. So let's talk about the first 2 pieces here. I'm going to use a different marker so we can actually see what we've got here. This way it's easier to see. Look at what I've got underlined. That's the first 2 pieces. What do they have in common? What can I factor out of what I've got underlined? Can someone tell me? X can come out. So X comes out, and that leaves me with an M plus Q. That's the first 2 pieces. Now we do the same with the last 2 pieces. So what can come out of the last 2 pieces? A Y can come out. And that leaves me with an M plus Q. Now, what we just did a minute ago was we factored out those groupings, right? The parentheses. Are those parentheses exactly the same? Yes, they are. Okay, that comes out. So that means my final answer would be M plus Q. That came out. So gone, covered up. Okay, and what's left over? Yep, X plus Y. That's it. And that's your final, finished, factored answer. How do I know I'm done? Look at each set of parentheses. M and Q, do they have anything in common? No. X and Y, do they have anything in common? No. So they're done. 53. A little bit different, but again, pretty much the same. So 53 is 10M plus 2N plus 5 mk plus nk. So, very first thing I look at is I see if they have anything in common with all the pieces at the very beginning. I've got a 10, a 2, and a 5, but this one has nothing in common, so it can't come out, no coefficient. And then we've got an M and an N, and we've got K's over here, so nothing's in common, right? Always look to see, can I take something out of all the pieces at once? Nothing can come out. Most of the time, you're not going to be able to. But there are several cases where you're going to have to. Nothing comes out, so now we're going to factor by grouping. So we group the first two together. What can come out? 2. Anything else? Nope, doesn't look like it. So the 2 comes out, and that leaves you then with the 5m plus n. Next two pieces, what's going to come out of here? Looks like what can come out? Can someone tell me? K can come out. Now, here's how you know you're doing it correctly. These parentheses had better be the same. If they are different, you made a mistake. No doubt about it. If these are not the same parentheses, you made a mistake. So when I take that K out, what's left over? 5n plus n. Are these parentheses exactly the same again? Are these the same? Yes. So that means it comes out. So 5m plus n comes out. You can cross it off. Right? Okay, gone and gone. What's left over then? 2 plus what? 2 plus k. That's it. Nothing comes out. Nothing comes out. We know we're done. That's your final, finished, fully factored answer. Okay, let's try another one. Let's look at, how about, we'll do 56. We'll do question 56, and then we're going to look at one where we have to rearrange the order to make it factor. So let's look at 56. We've got 20 plus 5m plus 12n plus 3mn. Nothing comes out of all of it. Always check that first. Nothing comes out. In some cases it will, and we'll look at one here in a moment where something will actually come out of all of it at the beginning. Nothing comes out though. So now we group first two pieces. What comes out? Anyone want to tell me what's going to come out of here? 5 comes out. And what does that leave you with? 4 plus m. Next two pieces. What needs to come out? Okay, an n comes out, and what else? Yep, 3. So a 3 and an n comes out. We know that we did it correctly because what is left over should be the same as what's over here. So 12 divided by 3, that's a 4. The n's cancel, so those are matching. So we're on the right track so far. The 3's cancel, the n's cancel, and what's left over? An m. Now, are my groupings, the parentheses, are they the same? Yep. So then what do we know? We know that what's going to come out in front is a 4 plus m. Gone and gone. What's left over now? 5 plus 3n. And that is your fully factored, finished answer. They're not too bad once you start getting the hang of how these work. Okay. Question number, let's see, if we look at 58, 58. Okay, 58, we're going to have to rearrange the order here, I believe. So let's look at question 58. We're going to have to rearrange the order. And in some cases, when you look at these, it might make sense to write them in a different order so that something goes together. I am going to have to rearrange this order. Now, the reason why I'm going to have to rearrange this order is the first two pieces, they don't have anything in common at all, do they? Right? And that's got an r squared, but look at these. These have r's on them. So let's rearrange it in a little bit different order. Doesn't matter the order that you pick. You just want to make sure that everything has something to factor out. So let's group and rewrite this r squared. Let's put it with the 3rt. So I'm going to rewrite it in a little bit of a different order here. So I'm going to now rewrite this as r squared minus 3rt. Now, why did I do that? Well, now I can factor out an r, right? So see how something comes out. Then we still have the minus tw and a plus 3rw. So that has something that can come out as well. This is also going to make us learn another important step here, when you have a negative that has to come out. So the first two pieces, we're going to look at these, and what can come out of the first two pieces. An r can come out. So that's going to leave you then with an r minus 3t. Is everyone okay with that? Now here's where we have to add on a new technique though. We have to be very, very careful with our signs. Notice the signs inside of our parentheses are positive and negative. Now look at the signs up here. Negative and then what? Positive. I need to switch the signs out. Whenever your first piece begins with a negative, like this one does, if it begins with a negative, you're going to have to factor out a negative. So that second two pieces, they begin with a negative. So I'm going to have to factor out a negative. And I'm going to have to factor out 9 and 3 have a 3 in common. So I'm going to take out a negative 3. And then I also need to take out what? And then I also need to take out, now let's make sure it all works out the way I want to. Well, we'll just take out a positive 3 in this case. This is the way it'll work, because otherwise it won't. We'd have to rewrite it again and again. But let's just take out a positive 3. If we take out a negative, it'll make it not work, because you'll see in a moment. Sometimes you have to adjust things around a bit. Normally, though, you'll take out a negative if it begins with a negative. This one's a little bit different. So then what else needs to come out? We got a 3 that comes out. We also need to take out what? We also need to take out a w. And what's going to be left over? What's going to be left over is minus 9 divided by 3. That's a minus 3. The w's come out, and that leaves you with a minus 3t. The 3's cancel, the w's cancel, and that leaves you with an r. Now, we need to make sure that these parentheses are the same. They may look slightly different, but we need to make sure that the signs for each part are the same. If I would have factored out a negative 3, it would have changed my signs and they wouldn't match up. So make sure these are the same. So let's look. Our r is here, r is here. Both are positive. The 3t is negative here, and the 3t is also what? Negative there. So those are the same. They're just in a different order. And remember, order doesn't matter. So these are the same. You just have to watch the order. So since those are the same, then what can come out? Bless you. what can come out is an r minus 3t. They are the same. Gone and gone now. And what's left over? R plus what? 3w. You've got to be very careful and make sure that your terms have the same signs. Normally, though, if it begins with a negative, you factor out a negative. But if I would have done that, the signs wouldn't match up in this case. So you always have to kind of look ahead and make sure that your signs are going to match. If they don't match up, then you have to rework it again. Let's do a couple more of these. Let's do another one where we have to rewrite and rearrange. How about we look at question 67. So we've got 8 plus 9y to the fourth. And then we've got a minus 6y cubed and minus 12y. So on this one, let's rearrange these. Doesn't matter how you rearrange it, you just need to make sure that something will go together with something else. So we've got different ways of doing it. You'll end up with the same answer. But what do we know about this 8? Well, this 8, it can either go with the 6 or the 12. Doesn't matter. Let's just go ahead and group the 8 and the minus 12y together. Okay, so let's go ahead and do that. And let's make that as an 8 minus 12y. And then we've got a 9y to the fourth and a minus 6y cubed. Okay, so now we've rewrote it. And why did I pick this order? Well, something will go together, right? Because 8 and 12, well, they have a 4 in common. 9 and 6 have a 3 in common and also a y. Now, we do need to make sure that when we factor something out of the second two pieces, that they're going to match to the first two pieces. So the first two pieces, we're going to factor out a 4, because that's what they have in common. So I'm going to factor out a 4. And that is going to leave you then with a positive 2 and a minus 3y. What about the next two pieces? What can we factor out of the next two pieces? Now, a 9 and a 6, right? They have a 3 in common, but we have to be very, very careful. If I factor out a positive 3, that's going to leave me with the positive 3 here, but this 3 is what? Negative. See how they're different? So we need to make sure that the 3's are the same signs. So this one's negative, this one's positive. So we're going to factor out a minus 3 so that the signs change and they match up. And then we can also take out a y cubed. Sometimes you may have to factor out a negative to get things to rewrite and rework in the correct order. So when I factor out that minus 3, 9 divided by a minus 3, 9 divided by a minus 3, that leaves you with a minus 3. We've got a y to the fourth. 3 of them are coming out, so that leaves you with a minus 3y. Now, look here. Those are the same, aren't they? You have to be identical. If they're not the same, you made a mistake. The signs have to be correct, which they are. Variables and everything have to be right. Now, what about the next piece? Minus 6, we're going to divide it by a minus 3. Minus 6 divided by a minus 3. Negative and negative makes it a positive. The y cubed came out, so that left you then with a 2. Okay? Might be in a different order, but that 2 is positive here, and that 2 is positive over here as well. So we know we did it correctly. Now what can we do? Now these groupings are the same. They look slightly different, right? But they are the same. Order doesn't matter. Just make sure that this one's negative and the 3 is negative here also. So go ahead and factor it out. So I'm going to factor it as 2 minus 3y. And if that's gone and that's gone, then what's left over? 4 minus 3y cubed. And that is your final, finished, factored answer. And sometimes with the negatives, you've got to be careful about the order and the signs. Question 72, we're going to have to factor out something at the very, very beginning. Remember, we always want to check and make sure that nothing comes out at the very, very beginning. All the others, we haven't had to worry much about it yet. But this one, we've got to factor out something at the very, very beginning. When I look at all of these, I've got a 12, I've got a 6, an 18, and a 9. All of these have what number in common? 3. Okay, so always, always, always check first to make sure nothing comes out. That's step number 1 and the most important. If there is something in common, it must come out to make this work correctly. So these all have a 3 in common. Bless you. So we're going to place a 3 out in front, and we're going to see what we're left with. Well, 12 divided by 3 is a 4. 6 divided by 3, it's a negative, so we're going to leave you with a minus 2q there. Then we've got a minus 18 divided by 3. Well, 18 divided by 3, that leaves you with a minus 6p. And then we've got 9. 9 divided by 3. That leaves you then with a positive 3 p q. Okay, let's double check and make sure we did it correctly. 12 divided by 3 is 4. That's right. 6 divided by 3 is 2. That's right. The negative just came down. 18 divided by 3. That leaves you with a 6. The negative came down. 9 divided by 3. That left you with a 3. Now, we're not going to have to change the order. Why not? Well, when I look at these, is there something that can come out of all of this? Not of all of it, but each piece. Okay, if I look here, what I've got underlined, can something come out of that? Yeah. So we don't have to rearrange it. The only time you have to rearrange it is when it's like this. Like on this one, 8 and 9 have nothing in common. So I had to reorder them because a 12 and an 8 could go together. This one, though, they have something in common, so we don't have to worry about it. The order, it's done. So what can come out? Someone said it. We need a 2. And what's that going to leave me with? That's going to leave me with a 2 and a minus q. The next two pieces. Okay, what can we factor out of here? Can someone tell me if we're going to factor out a 3 or a negative 3p? Which one? Negative. Okay. Why am I going to want to try to factor out a negative? Well, we know we're going to factor out a minus 3p because when I do that, let's double check and see what happens. When I factor out a minus 3, negative 6 divided by negative 3, that leaves you with a positive 2. See how they match? Signs are correct there. What about the next one? 3 divided by negative 3, that leaves you with a negative 1. And the p's are gone, so that left you with a negative q. Are these groupings the same? Watch your signs. 2 is positive, q is negative. So are they the same? Yes. Okay. So these can go together. And we're going to rewrite it. And then what we have is we have 2 minus q. Gone and gone. And then we have a 2 minus 3p left over. And then do not forget about that 3. That 3 was out in front. All right, so 3 is just going to come down. So that's your final, finished, factored answer. Now I'm going to give you something, and you're going to tell me if this is factored or not factored. I want you to tell me if this is factored or if it is not factored. Now, if it's factored, that means nothing comes out. When I look at this 5x squared plus 8x, is it factored? No, it is not. Okay, it is not factored. And why is it not factored? It's not factored because what can come out? Well, yep, just an x can come out, and this would make it factored. Okay, so it's not factored, and there are several questions that ask you this. If it's factored or not. This one is not factored. Okay, let's try another one. We'll just do 2 or 3 of these. Is this going to be factored here? 8x squared plus 6x minus 2. Well, let's not use a 2. That'll make it factored. How about minus 3? Okay, now, is this one completely, fully factored, yes or no? Okay, if it's not factored, then what can come out? No, x can't because it doesn't have anything there, right? Okay, for it to be completely factored, nothing can come out. Let's look at the numbers. Let's check the numbers. 8, 6, and 3. Do they have anything in common? No. Nope. Now 2 can't come out of that 3, can it? No. Right. So that's why I made this one. This one is already factored. And how do I know it's already factored? It's already factored because nothing comes out of here. 8, 6, and 3 have nothing in common. Nothing can come out. That 3 is missing that variable x, so it's done. There's nothing that can come out of here at all. Let's try another one. Let's see, is this one factored? Is this one factored? Yes or no? Would this one be factored? Yes or no? Nope, it's not completely factored. Why is this one not completely factored? Right, because these are the same, right? So that can come out, and that would leave you with then an x minus 5 out front. And what's left over? Okay, 4x plus 9. Let's try another one. I'll give you one more. And let's see if we think this one's factored. Okay, is this one right here? Has this been factored? Yes or no? No, it has not been completely factored. Okay, now notice the parentheses. We always need to check and make sure with each parentheses, they're independent, make sure that nothing can come out. And this one is not factored completely. So the answer for this one is no, because when we look at my first set, can something come out of this first set of parentheses here? Yes, 6 and a 9 have a what in common? A 3. So that 3 will come out. And that's going to then leave you with 9 divided by 3 is a 3x. 6 divided by 3 is a 2. And then you're left with a 2y minus 3. So this one is not completely factored because we can go a little bit further with this set of parentheses here. And whatever comes out, you just put it in front. And it doesn't have to come out of both sets of parentheses. It just has to come out of one of them. So whatever comes out in one, you put it out in front, and then you factor what's left over. Let's now take a short break. We're going to come back, and we're going to move on to the next section, which is how we factor 3 terms.